So we can divide our elements into three main categories: metals, nonmetals, and metalloids, which is what we did in lab. So before we get to exactly what materials from lab were each of these categories, we are going to talk about some of the properties. And we observed many of these properties during lab. So first we're going to start with metals. Metals, when we look at them, we notice that they are shiny. So metals have a shiny appearance. We also tested their conductivity. Metals can conduct electricity. Are also good conductors of heat, but we tested their conductivity of electricity. So metals can conduct electricity. We also noticed that metals are malleable. And remember, malleable means that we can bend them. They're bendy. We can also say that metals are ductile. Ductile is similar to malleable. Ductile just means that you can draw it out into a wire. We can make wires out of metals. We do that all the time. So metals are shiny, they're conductive, they're malleable and ductile, and then finally they are reactive. With some of our metals, we saw an immediate reaction with hydrochloric acid. Some of the metals, if we had let them sit, we would have seen over time a clearer reaction with hydrochloric acid. But our metals are reactive. Our metals also happen to be our most common type of element that we have. So when you're looking at the periodic table, and we'll get to that in a minute, most of the elements are metals. So we're going to look at the other end of the spectrum, and we're going to look at nonmetals. Nonmetals have very different properties from metals. If metals are shiny, nonmetals are dull. So all of our nonmetals are not shiny at all. Our nonmetals are not conductive. Non-conductive, which means that they don't conduct electricity. Our nonmetals are not, you can't bend them, you can't make them into wires. They are brittle. They will break if you try to bend them. And then finally, if metals are reactive, our nonmetals are non-reactive in their elemental form. So our metals and our nonmetals have pretty much opposite properties. If our metals are shiny, our nonmetals are dull, they're not shiny. Our metals are conductive, our nonmetals are not conductive. Our metals are malleable, they can bend. Our nonmetals are brittle, they're going to break. Our metals are reactive, our nonmetals are not reactive. So then our last category is a metalloid. And a metalloid really has a blend of the properties of a metal and a nonmetal. Just like a metal, metalloids are shiny. Also like a metal, they are conductive. They may not be as conductive as a true metal, but they can conduct electricity. So those are the two properties that metalloids have in common with metals. With nonmetals, they are brittle. So they're going to break, they don't bend, and they are also non-reactive. So we're not going to see our metalloids react with hydrochloric acid. So those are the descriptions of our different categories. So from our lab, our metals would have been aluminum, and I'm just going to write the elemental symbols for them, but they were aluminum, copper, gallium, lead, and magnesium. So we tested 8 different elements. 5 of them were metals. So aluminum, copper, gallium, lead, and magnesium were all metals. Our nonmetals were carbon and sulfur. So we had 2 nonmetals. Carbon was a nonmetal and sulfur was a nonmetal. And then finally we had 1 metalloid, and our 1 metalloid was silicon. So that's where our 8 elements fell in the realm of our classifications. So we had 5 metals, 2 nonmetals, and 1 metalloid. So now let's look at where all of these things are located on the periodic table. So we can use locations on the periodic table to help us determine if something is going to be a metal, a nonmetal, or a metalloid. Since most of our elements are our metals make up most of our periodic table. Now, there is a dividing line right here. I think I've lost count. I think that's right. The periodic table isn't exactly to scale. But there is a dividing line that separates our metals and our nonmetals. So this whole location over here, these are our metals. And they are in different categories. So we have alkali metals. We have alkaline earth metals. This whole chunk here in the middle are called transition metals. And then the black that's at the bottom of the periodic table, those are the synthetic metals. That means these are the metals that are man-made. They're elements, but they're man-made. They're not found in nature. Kind of over here, as we approach the dividing line for metals and nonmetals, these are poor metals. That doesn't mean these are metals that don't have a lot of money. It just means they're metals that don't really act like good metals. So they're maybe not the shiniest of metals. They're not the best conductors. Right along this line, right here, these are our metalloids. So right along that dividing line, we have our metalloids. And that's really hard to read, so I'm going to go ahead and erase that. And just write metalloids. So we have our metals, which make up most of our periodic table. Our metalloids run that line right between our metals and our nonmetals. And then what's left are the nonmetals. Now, the one element that's not in the right spot is hydrogen. So hydrogen's over here. Hydrogen, though, does not behave like a metal. Hydrogen is a nonmetal. We'll learn later why it's in this spot and not over here with the rest of the nonmetals. But if we're thinking generally, if you're looking at your periodic table, most of the periodic table are going to be metals, and it's going to be on the left-hand side of the periodic table. So you'll take your stair step, your zigzag line, everything to the left of the zigzag line are metals. What's right along that zigzag line are the metalloids. And then just in this top right-hand corner, those are our nonmetals. And then down below our periodic table, those are also our metals. Those are just synthetic metals. One last thing about how our periodic table is organized. If you'll notice, I didn't draw rows and columns on here, but if you look at your periodic table, they're organized into rows and columns. The columns are called groups. Or families. That means all of the elements within a single column have similar properties to each other. So if we have an element that's right here, and then an element that's right below it, we know that those are going to behave similarly because they're in the same family, they're in the same group. And then we have rows on our periodic table, and our rows are called periods. So we have our groups that go up and down, and we have our periods that go across. So our groups and our families have similar properties to each other, and then our rows or our periods we'll learn about more later about why they're organized that way.